here. Preferences is structural. First step, element type. We have added the plain 182 element. Under the element option, we will on the third option is there, plane strain is there. So we'll on that plane strain, click OK. So it does not take a real constant. You try to add, you may get some error, not define add for the plane 182. Please check and change the key point setting of the for plane 182 element before proceeding. Okay, so it will not take a real constant. Plane stress and plane strain does not take the real constant, else you will give the option plane stress with thickness. Okay, right? So plane strain, that is the length is very large in as compared to the cross section area. As compared to the cross section area, you observe here, in case of retaining wall of the dam or in case of rail track, right here, the length is very large as compared to the cross section area. So very small change in length will be does not affect on a strain, as strain is change in length to the original length, as original length is very large or it is infinite. So strain in z direction will be 0. Okay, so again, material models, we will add a regular material, structural steel, linear, elastic, isotropic. Now we are using the retaining wall of the dam. So what is a Young modulus? Anyone? What is the Young modulus for the RCC? It is approximately 2.7 e raised to 4. You can cross check that, and Poisson's ratio is 0.25. Right? Retaining wall RCC से आता property use करायला लागतील, right? You cannot use steel. You cannot. You can search for that Young modulus, and you can Google that also, or you can get in any of the civil book, right? So as changes the material, right now here material for the retaining wall of the dam will be RCC concrete, right? So you have to select appropriate values of material property. What is the meaning of WB? Workbench? Yeah, definitely. You may automatically get that value in workbench. Okay, because we have saw in the material library all the properties are defined. So definitely you get that pronoun in workbench. Okay, I am approximately entering the value. It is maybe slightly vary in a range. Okay. Once we add the key point, I will create the key point on a work active coordinate system. So first key point at a location of 0, 0. Okay, at the origin apply. So first key point is at here. Second key point at the distance of 300. Apply. Now third key point at a distance of 300. Apply. The fourth key point at a distance of 200, 500. Apply. And fifth key point at a distance of 0, 500. Okay, right? 1, 2, 3, 4, 5. 5 key point will there. So what will be there? I will create now line, straight line, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Obviously, again I am this given as a random. You can again consider the different nature, right? The different nature of the cross section, right? Now I will create the area arbitrary by lines. So I will pick the lines 1, 2, 3, 4, 5 and click on OK. So it will create the area, plot area. Okay. So how we created the area? We have first created the point, then we have created the lines, and we create the a arbitrary area through lines or by lines. So we'll select the multiple line automatically. Depend upon the lines, it will generate the cross section area. Okay, plot key point. You can get this 5 key point. Plot lines. These are the 5 lines. Plot area. This is the area. Okay, so very simple modeling is there. Now go to the mesh tool. Right now, this is now you cannot form the map meshing here because whatever the area is consisting of more than 4 sides. Okay, so you will try to mesh. Suppose I will define the edge length, apply 20 mm. Okay, and we'll try to map mesh. You will try to map mesh of area. It will show the area will be irregular. Right, area one is regular, cannot be meshed with quadrilaterals. Okay, so why it is irregular? Because you go to the mesh tool, when you click on map mesh, the area may be consisting of 3 or 4 sides only. So you can go to the free mesh. Okay, mesh now, and okay. Right, again it will showing the message that or warning will be created. It will be creating the triangular element. Okay, so you can observe here one triangular element is created, and here and here in this region there is a damage to the mesh quality as wrap angle is changing and all that things. We are going to study that in unit number 3. What is the wrap angle, what is the aspect ratio, and all that thing. Right, so this is meshing is been done. Right, 3 mesh we have created. Then go to the loads, define load, apply structural displacement on lines. You will select the bottom line or bottom edge, apply. We will select all degree of freedoms 0. Okay, all degree of freedoms 0. Okay, then we go to the pressure. So to apply the variable pressure, because at the top of the here point the pressure is minimum, and at the bottom the intensity of pressure is maximum. So apply on the beam with, sorry, we apply the pressure on line, select that, apply. Okay, so here is suppose 10 is given, and if the constant value PRS at the node J, so at I and at node J you have to apply the both the value. Here will I apply 100. Okay, at the top here the value will be we'll check what is the nature, how is being applied, what is the node I. In node J it will be considering, right, and they will then go to the solution, solve current LS. Okay, now we are going to view the result. Nodal solution, DOF solution. We will try to plot the displacement first. Right. So we have constraint here, right, and this is the pressure is being applied. Pressure is being applied, right. Or you can get the directional stress also. Directional displacement, X component. Okay, Y component. Okay, now main stress, strain, elastic strain, you have to look for the z component, right? Z component, right? It must show the zero value. Look for that, right? So displacement is maximum, you don't get any value of strain, right? When you plot for the x component of strain, you get certain value. You can get for the y component, you get certain value. But the strain in z direction is absent or it is zero. Strain is zero, but trace is not. So you can go to the nodal solution, trace z component. Okay, right? There is some value. X is also there, y is also there, right? You can observe for the x also. So x is also there, right? So from that you can conclude that this is a strain, elastic strain, right? We are under the considering the elastic material. We are not considering the plastic or creep. There is also options are there for the, suppose you are doing the creep analysis or thermal analysis, then you can plot for the elastic strain, plastic, creep or thermal. Okay, z component will be zero. So this is the way you can do the plane analysis of plane strain problem. Strain in z direction will be zero. Strain in z direction will be zero. Okay.